For most of human history, the stars have been distant lights, unreachable, eternal, and mysterious. But today we stand at the edge of something extraordinary. For the first time, humanity has not only looked to the stars, but begun to imagine reaching them. The question is no longer if we can leave our solar system, but when. The dream of interstellar travel has long been fueled by science fiction. From warp drives and wormholes to cryo-sleep and generation ships, stories have helped shape our vision of what lies beyond. But science fiction is slowly becoming science fact. Let's start with what we have now. Our most distant spacecraft, Voyager 1, launched in 1977, is still sending signals back to Earth. It has officially entered interstellar space, a region beyond the influence of our sun's solar wind. But Voyager is moving at just 17 kilometers per second. At that speed, it would take over 70,000 years to reach the nearest star system, Proxima Centauri, which lies 4.2 light-years away. Clearly, if we want to explore beyond our solar system in any meaningful way, we'll need faster and more advanced propulsion technologies. One promising concept is the Breakthrough Starshot project. This ambitious initiative proposes using powerful ground-based lasers to propel small, lightweight spacecraft, about the size of a smartphone, attached to ultra-thin light sails. Theoretically, these craft could reach up to 20% the speed of light, allowing them to travel to Proxima Centauri in just 20 years. While challenges remain, like avoiding collisions with interstellar dust, the concept represents a radical shift in how we might explore the stars. Another possibility lies in fusion propulsion. Unlike chemical rockets, which burn fuel quickly and inefficiently, fusion propulsion could provide sustained thrust using reactions similar to those in the Sun. Projects like Project Daedalus and Project Longshot have proposed using fusion engines to reach nearby star systems within a human lifetime. While we haven't yet mastered controlled fusion on Earth, rapid advances are being made, and fusion-powered starships may be within reach by the next century. But even if we solve propulsion, we face another daunting challenge: time. Space is vast, and even our closest neighbors are unimaginably far. This raises the idea of generation ships, massive vessels where multiple generations of humans live and die during the journey. These ships would be entire ecosystems, self-sustaining and carefully balanced. The people who arrive at the destination would be the descendants of those who first launched the mission. Alternatively, we could explore the idea of suspended animation, placing astronauts into a deep sleep to minimize life support needs during the voyage. While still theoretical, advances in medical science and cryobiology are making this concept more plausible than ever. Of course, before we send people, we'll send machines. Autonomous AI-powered probes could map exoplanets, analyze atmospheres, and even build infrastructure long before humans arrive. These robotic scouts could prepare distant worlds for colonization or send back data to help us decide where and whether we should go. Which brings us to the ultimate question: why go at all? Why risk so much to leave the solar system? Part of the answer lies in survival. Our planet, while beautiful and life-giving, is vulnerable to natural disasters, cosmic events, and even human mistakes. By spreading out into the cosmos, we reduce the risk of extinction. In a way, becoming an interstellar species is the ultimate backup plan. But there's also something deeper, an innate drive to explore, to go beyond, to reach for the unknown, not because it's easy, but because it defines who we are. Colonizing other star systems may also unlock untold resources: energy, materials, even new biological insights. It could trigger revolutions in science, culture, and our understanding of life itself. If we discover life beyond Earth, microbial or intelligent, it would redefine everything we know about biology, consciousness, and our place in the universe. Of course, we must proceed with caution. Ethical considerations around space colonization, the preservation of alien ecosystems, and the role of artificial intelligence must be taken seriously. The stars are not ours to claim, but to approach with humility, curiosity, and responsibility. In the coming decades, we'll see space telescopes capable of analyzing the atmospheres of exoplanets. We'll continue developing propulsion systems that defy current limits, And maybe, just maybe, we'll witness the first whispers of a future where humans no longer belong to just one star. The journey beyond our solar system is the next great chapter in the cosmic story. A story not just of technology and ambition, but of imagination and of hope. But space exploration isn't just about reaching the stars. It's about thriving once we get there. To do that, we'll need to solve some of the most complex problems in human history. Creating sustainable life support systems, building artificial gravity environments, shielding ourselves from cosmic radiation, and developing closed-loop ecosystems that can support life indefinitely. One idea is to construct habitats on moons or planets in other star systems. Terraforming, transforming an alien world into one that can support human life, is a popular idea, but incredibly difficult. It could take centuries or even millennia to change an atmosphere, stabilize a climate, and seed life. Alternatively, we might build massive space-based colonies, orbiting habitats like the O'Neill Cylinder or the Stanford Torus. These structures, spinning to simulate gravity, could house thousands or even millions of people, complete with farms, forests, and even oceans. But as we look ahead, some thinkers imagine even more profound possibilities. What if we could merge with our machines, transcending biology entirely? Advanced civilizations might not travel with bodies as we know them. They may upload consciousness into robotic vessels, or even exist as pure information. Digital minds journeying through the stars at light speed. If this sounds like science fiction, consider how fast our technology is evolving. A few decades ago, spaceflight was the stuff of dreams. Today, we're mapping exoplanets, designing fusion drives, and simulating entire biospheres. Some predict the rise of post-human explorers, AI-human hybrids or fully synthetic beings, capable of enduring deep space travel far better than fragile human bodies. These beings might not just explore space, they might become something entirely new. Yet amid these bold visions, we must also consider the cosmic timeline. The universe is still young compared to its future. Stars will continue forming for trillions of years. Civilizations may rise and fall across the ages. The galaxy might one day be filled not with lonely silence, but with thousands of species, traveling, thriving, and telling their own stories. In the grand arc of cosmic history, our journey beyond the solar system could be just the beginning of a much larger transformation, not only of our technology, but of our identity. What does it mean to be human when we're no longer bound to Earth? What cultures, beliefs, and ideas will we carry to other worlds? And how will the vastness of interstellar space change the way we understand ourselves? These are questions we may not answer in our lifetime, but the seeds are being planted now. With every satellite launch, every deep space probe, every telescope capturing the light of distant suns, we are writing the first words of the next chapter, a chapter in which Earth is just the opening scene, and the rest of the galaxy is waiting to be discovered. If the mysteries of space ignite your curiosity, if you dream of galaxies, time, and the future written in the stars, then you're in the right place. Subscribe to Cosmic Storybook, where every video turns the wonders of the universe into a tale you'll never forget. Let the cosmos unfold, one story at a time.